Countries around the world are racing to replace fossil fuels with sunlight, requiring massive swaths of land and hardware. To meet Malaysia's target of 57 gigawatts of renewable energy by 2050, installations like this are scaling rapidly. But the technology driving this transition has a built-in expiration date. Solar panels degrade under the sun's harsh UV rays and heat. After 10 to 15 years of operation, a typical module loses about 20% of its original electrical efficiency. Once they hit that threshold, utility companies swap them out for newer models. By 2050, this replacement cycle is projected to generate roughly 212 million tons of decommissioned solar panels worldwide. We are trying to solve our fossil fuel problem by engineering a delayed avalanche of electronic waste. Dumping these modules in standard landfills is a hazardous short-term fix. Solar panels contain trace amounts of toxic heavy metals, like lead and cadmium, which can slowly leach into the surrounding groundwater as the hardware breaks down in the elements. The alternative is recycling, but pulling a solar panel apart is incredibly difficult. You have to mechanically dismantle the aluminum frame, shatter the protective glass, and use chemical baths to dissolve the internal layers just to extract the valuable silicon, silver, and copper. Right now, that process simply cannot scale. Specialist recyclers struggle to secure financing because the raw materials they recover actually cost more to extract than simply mining virgin metals out of the earth. Landfills are toxic, and chemical material recovery is economically starved. The renewable industry desperately needs a third option for handling this hardware. At the University Putra, Malaysia, researchers at the Puchong Showcase are testing a completely different model. Instead of melting dead panels down to their base elements, they are treating them as high-durability building materials. Before any panel is repurposed, it goes through a strict triage process. The team uses thermal cameras and electroluminescence imaging to scan incoming modules, searching for dangerous microcracks or localized hotspots that could fail in the field. This diagnostic table outlines their criteria. Any panel with structural or safety defects gets filtered out, while those retaining at least 70% of their original capacity are kept. By putting the hardware through this diagnostic filter, a discarded piece of e-waste becomes a verified physical asset ready for deployment. In this layout, Second Life panels replace metal decking as weatherproof roofing for the learning center and serve as perimeter fencing. But their most valuable application is in the dirt, where intense tropical sunlight stresses high-value crops, reducing their yield. Deploying these modules over the crops creates a perfect physical symbiosis. The degraded panels block just enough sun to maintain a 40 to 60. In contrast, deploying Second Life panels onto a farm directly offsets the costs of purchasing new building materials, making the economics immediately favorable. Yet, scaling this model nationwide hits a massive bureaucratic wall. The primary bottleneck isn't the technology, it's the strict safety codes enforced by Malaysia's Energy Commission and SIRAM. As this regulatory breakdown explains, grid-connected solar equipment requires rigid certifications. Once a panel is decommissioned or structurally modified, it loses its original manufacturer warranty. Under existing rules, it becomes legally prohibited from generating power on a commercial network. The UPM sandbox exists specifically to solve this. The researchers are applying for a temporary regulatory waiver, allowing them to operate a hybrid microgrid. This will generate the hard data on electrical leakage and grounding safety needed to draft an official national standard for Second Life solar. True sustainability requires closing the loop. By taking the obsolete, cast-off hardware of the clean energy transition, we can build the low-cost infrastructure necessary to protect and power our future food supply.